This video, we're going to go through an example of a context-free grammar for a language which we know is not regular. And as a result, we're going to prove that the context-free grammars are more powerful in terms of their expressive power than the regular grammars. What I will need you to remember for this video is the definition of a context-free grammar, as I gave it before. And you will need to know the fact, which we proved before, that this particular language, which is the set of strings where we have A's before B's, and the number of A's is the same as the number of B's, the fact that that language is not regular. So if you don't know that, I would suggest looking back at your lecture materials through Echo. The other thing that will be sort of important to keep in your head a little bit, but I won't use it directly, is the Chomsky hierarchy that we've talked about in this course. So just keep that in the back of your mind, the fact that we've got this hierarchy of sets of languages, because this will tie in with that a little bit. So what we would like to prove is that there are languages which we can generate using a context-free grammar that we cannot generate using a regular grammar or a regular expression, and that we can't accept using a finite state machine. So we have an important set of languages, the regular languages, and we know that quite well. And I'm going to denote it by this little curly R. We also know that there is a set of languages which gets generated by these context-free grammars that we've introduced, and I'm going to denote it by CF. Now, neither of those symbols are by any means mathematically standard, so don't go using them elsewhere and expecting people to understand them, but to make this video easier for you to read, I'm going to refer to the regular and context-free languages, or the sets thereof, by this R and curly CF. So in the universe of languages, we have one of these four options. Basically, they're the set of context-free languages and the set of regular languages can have absolutely no overlap, so there is no common languages between the two of them, which seems pretty unlikely. The other option is that neither could be a subset of the other, but they could have a non-empty intersection. Or they could be subsets of each other, and the context-free languages could be a proper set of the regular languages, or the regular languages can be a proper set of the context-free languages. Or there is one other option, and that is that the context-free languages is the exact same set as the set of regular languages. What we're going to prove in this video by doing an example of a context-free grammar is that this is the true case, that the regular languages are a proper subset of the context-free languages. And that will be helpful. So we want to prove that this is the case. What do we need to do? Well, we need to show that every single regular language is also a context-free language, which means that we need to prove that this statement is true. We also need to prove that there is at least one language sitting here that is context-free and is also not regular. So, mathematically, that means that we need to show that the set difference from the context-free languages and taking away the regular languages leaves us with a non-empty set. So, the first statement. This one is actually very trivial. We've shown already that the regular languages is the same set of languages as the set of languages generated by regular grammars. And when we were talking in the last video, we showed that every regular grammar is trivially a context-free grammar. That means that we can generate any regular language using a context-free grammar. So that one is actually very, very easy to prove. The next one is not quite so simple. So we have to show a language, we have to give an example of a language, and we have to show that it is not regular, and we have to show that it is context-free. As soon as we have come up with an example of a language which is not regular and which is context-free, then we're done. So, how do we prove the first part? Using the pumping theorem. So we do a proof by contradiction using the pumping theorem to prove that the language that we pick is not regular. How do we prove that it is context-free? Well, so far, our only definition of the context-free languages is the set of languages generated by context-free grammars. So, our only way to show that a language is context-free is to generate a context-free grammar for it. So, that's what most of this video is going to be about. We're going to do an example of a context-free grammar for a language which we have already proven is not regular. So, you know from the lectures that the language ANBN is not regular. So we've done the first bit. Now we want to use this as our example and generate a context-free grammar and show that it is therefore a context-free language. So the grammar that we will generate will be nice and simple. It will have a set of non-terminals, which is just a single non-terminal. It will have an alphabet of terminals, which you can pretty obviously see is just the letters A and B. Its start non-terminal can only be S, so that's pretty trivial. And its rule set will be the following. Nice and simple. So we can straight away see that we can generate the first element of this language, which is the empty string, just by applying the first rule, empty string generator. We can generate the string consisting of 1A and followed by 1B pretty easily by applying the first rule, and then applying the second rule. And now we have the string AB. Notice that at the end all of the epsilons disappeared because they are empty strings. But what you can see is that by repeatedly, you should be able to see, is that by repeatedly expanding this bit using this rule, we can generate each lexicographical, the next string lexicographically, by just expanding that once and then with an epsilon. So if we keep expanding that, we can keep shoving an A and a B in, and we'll end up with strings of the form AN, BN. Success. So we have generated a language, ANBN, and we know from before in the lectures that it is not regular, and we have just shown that it is context-free. So we have proven our assertion before that the regular languages are a proper subset of the context-free languages. So what you should know from this video is obviously that the regular languages are a proper set of the context-free languages, and you should have the beginnings of an understanding of how to build a context-free grammar for a language which is not regular. If you want some more examples of context-free grammars for non-regular languages, you can see the examples in the textbook.